Hello Year 10, welcome back to your next living room lessons. We are continuing our coasts topic today and we are going to be having a look at different types of landforms to what we were doing last lesson. So what you will need today is your exercise book, a pen and a ruler and a pencil again, because there will be a bit of drawing again, and your phones. Before we dive in, jog your memory time. I realise I say that every single time. Before we dive in, jog your memory. I bet I'm a meme somewhere, aren't I? So, 3 questions today. How are headlands and bays formed? How does abrasion shape our coastline? And give 1 positive and 1 negative of migration into London. So pause this video, scan the QR code or follow the link and go have a go at this, jog your memory for us, and please write your name in so we can see who is doing these. Okay, hopefully you've had a go at that. So what we're going to do, again, we did this last lesson, but I think it's really useful for us to do a bit of a recap on what we've just been learning. So a little bit of a recap on last lesson. We've got another exam question here. So we've got another photo of a coastline here, and we've got 4 different features labelled on it. And what the question says is use inference to state which 2 features in figure 2 are made of more resistant rock. So using inference obviously means that we're taking a very educated guess, don't know for definite, but looking at this, what can you infer? What places can you infer are likely to have more resistant rocks? So pause your videos, have a look at the 4 different landforms you've got labelled here. Which 2 are going to be created because of the rock being harder and more resistant? And just write down your books, just quick bullet points. Which of our 2 features do you think are more likely to be hard rock? Okay, so we're going to start off actually with the ones which we know are probably not going to be our resistant rock. So if our 2 that we would say are more likely to be softer rock are C and D. And this is because D is suggesting that this is our kind of coast, our bay. So this is our area of softer rock which has been eroded at a much quicker rate than the headlands on either side of the bay. So D, we can also see if you look closely that there looks like there's a bit of slumping or something there as well where our cliff has had a mass movement event. So this would be our softer rock. And then C is the beach. So the inside of the bay where the material has been deposited again is going to be much softer rock. Whereas A and B are much more likely to be our harder rock because they are landforms created from a headland. So A is our arch and B is our stump. Now these are going to take much longer to erode because they are more likely to be a hard rock. Which is why we end up with these large landforms being created out to sea, whereas the area around it, such as C and D, are eroded much quicker. Next little exam practice for you here. So rates of coastal erosion are faster during stormy weather. Match the 6 key terms to the correct definitions below. 2 terms are not needed. So read through, this is a bit of a recap on a lot of stuff we've been doing actually. So this is a recap on coasts, on climate change and on weather. So wow, mind's blown, busy, busy, busy. So read through these 6 definitions and then match up which of these words describes that, is the correct word for that definition. Okay, let's go through these then. So our first one, a weather system that causes strong winds. So we know our strong wind systems, likely to be a hurricane or a storm, are our low pressure weather hazards. High pressure is when we have still calm conditions, low pressure when it's windy, rainy. Erosion, which causes the coastline to retreat, would be cliff recession, because that erosion has made the cliffs retreat further inland. The direction from which the wind most often blows is the prevailing wind. That is the prevailing wind is the term we use to describe the direction that the wind blows most frequently. A measure of the distance that has been travelled by the wind across a sea or an ocean is the fetch. Remember, we did this on the first coast lesson. So fetch is how far the wind has blown across the sea. Extra large waves and high sea levels caused by low pressure. These are storm surges. If you remember, our tropical storms will create storm surges, or just normal storms will create storm surges, which is when the water gets displaced and it creates these big destructive waves. And then the last one was a bit of a trick question because we haven't actually done this yet, but wanted to see if any of you could get it. So a measure of the amount and speed of water flowing in a river is the discharge. So discharge is the amount of water flowing in a river. So the title in your books for today is coastal transportation and spits. So kind of similar to last lesson, but different in many, many ways, is we are looking at another coastal process today. So we were looking before at erosion and weathering and how they have impacted the coastline. And now we're going to be thinking about transportation on the coastline. So once that material's been eroded, it has to be transported somewhere. It doesn't always just stay there, otherwise we'd have big piles of rocks everywhere. So, and then we're going to have a look at a landform that is created by transportation. So title in your books today is Coastal Transportation and Spits. Could you write that in, underlined with a ruler? Okay, so similar to when we were looking at erosion, there are, just to throw more key terms at you, 4 different types of transportation. So transportation is material that has been eroded from the coastline, which is then moved by the energy of the waves. So when a cliff slumps, for example, and it retreats and we have all of this rubble at the bottom of the cliff, it doesn't just stay at the bottom of the cliff. As we know, cliffs aren't just made of piles of rocks sat at the bottom of them. They get moved. The sea will come in, the sea will take that material, and it will carry it along the coastline or out to sea. And this is what we call transportation. Now, as I say, there are 4 different types of transportation. So what I would like you to do is pause the video and watch this video on the QR code, which introduces our 4 different types of erosion for you. And once you've done that, I want you to make a copy of the key term, transportation, and then I want you to make a copy of this. So our 4 different types of transportation, a little diagram to show how they work, and then the quick little key term underneath them. So again, these are 4 more completely alien terms you've probably never heard before that you do need to learn. So make sure you fully understand the video, make decent sketches, and write out the definitions for these key terms. Okay, so we've spoken about what the 4 different types of transportation are, but the kind of key part of transportation on a coastline is to think about where it gets transported. Because actually, majority of material that gets transported along the coastline doesn't just get dumped out at sea. It ends up somewhere else further along the coastline. And this is down to a process that we call longshore drift. So longshore drift is the movement of material along a coast. Because, as I said, it doesn't go out to sea, it gets transported along the coastline. So hopefully a little animation will start here. So, the process of longshore drift occurs. Come on, animation, kick in. It's coming, I promise. It's all down to prevailing wind, which is already there. So our prevailing wind obviously is the main wind direction that it blows in from. Right, come on, let's give it a jump start. Right, so here's our material. So what will always happen, because the prevailing wind will normally be at an angle to a coastline, is it brings the material into the coastline at an angle. But due to our backwash, so from when the waves break and then they pull back out to sea, the material gets pulled back out in a straight line. But the prevailing wind will then blow it back in at an angle. Backwash will pull it backwards, and so on. And this then carries it along the coastline. So we have our process of backwash, which is the material being carried back into sea, and swash, which is the material being carried up the beach. And because of the prevailing wind, the swash will nearly always be at an angle. It's very rare that a prevailing wind blows directly straight onto a coastline. So because of this process of longshore drift and the movement of material, our material will be moved along a coastline, and it can travel really, really long distances until the energy completely disappears and then it just gets deposited on the beach. But we often find that a cliff might be eroded at some point on the coastline, it might be eroded in Saltmarsh, and then that material might get travelled 300 miles along the coastline to Devon before it finally gets actually deposited on a beach. So materials travel a great distance by this process of longshore drift. So what I would like you to do now is watch this video, which will explain it better than I just did. Only watch it up to 1:45, you don't need to watch the whole thing. And then I want you to make a copy of this diagram with all the labels under a heading of longshore drift. So write a heading longshore drift and make a copy of this diagram. Okay, we're going to get a little bit more complicated now, because what I would like you to do next is have a look at an image of a beach that has been really affected by longshore drift, and we can really actually see the process of longshore drift occurring on this beach. And what I'd like to do is answer these 5 questions in your books in full sentences to explain what we can find out about longshore drift on this beach. beach. So have a go at these 5 questions and I will go through the answers in a minute. So question 1, true or false? True or false? True or false? True or false? The material is being moved from north to south. So do we think that material is being moved this way along the coastline? The answer on that one is false, and we'll explain why in a moment. True or false, the wind is coming from a southeast direction. So is the prevailing wind coming in this direction? That one is true. And then the evidence to suggest that you are right, that you would be right if you said false and true, is we can see quite clearly that the material is being moved this way up the coastline because the prevailing wind is blowing it in at this sort of angle. It's being pulled back. Blowing it in, it's being pulled back. But a lot of it is then getting trapped on this side of this man-made structure. So this man-made structure is stopping that process of backwash from taking the material back out to sea. And it's stopping it from being transported further along the coastline. Because we've got this build-up on this side of the structure, we can see that it must be from a southeasterly direction. Now, the structure on this beach, you will have done this in year 8, so I'm intrigued to see how many of you remembered it. These structures are called groins, and the purpose of groins is to stop the process of longshore drift. Because if they weren't there, we wouldn't have these large chunks of sand. This beach would probably be lost. It would be transported much further away. So groins are put in place to protect the beach and make sure that the process of longshore drift doesn't carry all of the material away. So what we're going to come on to now is having a think about landforms that are created due to this process of deposition. And the landform we are thinking about is called a spit. So in your books, I like to do a little heading of spits. And the first thing I want you to do is just pause your videos and watch this video. This time you're watching it from 1:45 to the end. So it's the clip you were just watching. So you're now watching the second half of that clip, okay? So have a go at that and I'll be back in a minute. Okay, so now we need to have a little bit of an explain of how our spits are created. So what I've got on the board now are the kind of 4 stages in the creation of a spit. So what we've got is our coastline, we've got the process of longshore drift happening along the coastline, and what we've got here is the beginning of the creation of our spit and our saltmarsh behind the spit. So this is kind of over time. So this is the first step, second step, third step, fourth step. So first thing I would like you to do is make a copy of this diagram in your books. And I want you to leave space by each diagram and by this arrow. So there's going to be, in a minute, you're going to add 5 annotations on. So you need 1, 2, 3, 4, 5, which is confusing because there's only 4 numbers on there. Okay, so here are your 5 annotations. So what I want you to do now is go back to that diagram and add these 5 annotations to the correct point. So as I said, there is 4 on each of the images, and then the 5th one comes in on that arrow between image 2 and 3, all right? So copy these out in full next to the correct part of your diagram, and I will go through the answers in a minute. Righty, let's go through these then. So, the first thing is longshore drift moves material along the coastline. So material gets carried along a stretch of coastline. When the material comes to a change in the direction of coastline, it is deposited as the wave does not have enough energy to move it around the corner. So the longshore drift has been happily happening along this stretch of coastline, and then it reaches a point when the shape of the coastline moves. Now this could be because there's a river flowing out, or it could just be because we've got a different shape of coastline. But there's not enough power to turn it so it continues going along the coastline. So as long as there's not a lot of energy coming down, we will have the material continuing to be deposited. So it goes kind of on autopilot and keeps depositing it along the stretch of coastline. Over time, this material will build up and it will extend outwards. So it will extend out from the coastline, and this is what we call a spit. Over time, there might be a change in wave energy, a change in prevailing wind, and the material kind of stops being deposited and our spit starts to curve. So we start to get a bit of a shape on the end of that spit. And then eventually, because this spit has created this new area of really protected land, it's created like a new barrier. Behind the spit, a saltmarsh develops where the water is much calmer because our spit has protected the water behind it. So more land starts to develop and you start to get a saltmarsh, which is a really important ecosystem. So spits and saltmarshes are actually a really important landform, and there aren't loads of them about, but there is one out towards Chichester sort of way, so not too far away from us. So the last thing we're going to do today, that's been quite a nice quick lesson today, hasn't it, is I want us to have a think about how people might use spits. So as I've just mentioned to you, they're an important ecosystem because they create this salt marsh. But I want us to have a think about how else they might be used. So in your books, I want you to do a little mind map of how might people use spits. I want you to have a look at some of these images, and I want you to just write maybe 4 or 5 different uses of a spit. So how is this landform useful? I will talk you through a few in a minute, but I want you to have a go at this on your own first. All right, so having a look at these, we can see a few uses here. So this one's quite a nice obvious one. So often they're used as kind of like a harbour for boats because they create a really protected area on a coastline where there's not going to be huge destructive waves. So they're often a really good place to build a marina or a small dockyard. Also very often used as a for lighthouses because they're extended out to sea. So they're really useful in that they're not on the coastline, they're extended out a little bit. So they're a good point for kind of warning signals. And down here, we can see that it's used for kind of a bit of industry actually. We've got some, probably some dockyards, maybe something to do with fish or trade, because again, they're that extension out to sea. They're at a really good vantage point. They're also often used kind of for leisure activities as well. So often a really good place to go for a nice little walk or a cycle. As I've mentioned, they're good in terms of having the rare ecosystems there. So for a lot of kind of wading birds, they're good places to have nests for them because they're near the sea, which is what they like because they can do their fishing, but they're on land. So they're a really good spot for a lot of rare ecosystems. So spits are a really important landform. So that is it for today. Well done. Things you should have in your books are the 2 recap exam questions, the 4 different types of transportation, what longshore drift is from the diagram and the labels, the photo evidence questions, so that question of the beach and the 5 questions around it, a spit diagram and annotations, and then the how people use spits mind map. Well done, Year 10, you are brilliant, and hopefully I'll see you all very, very soon.